All right, let's continue where we left off yesterday. This is at about 10 minutes of this 20-minute tutorial using R for GIS and mapping by Blunder. And I've got R up, and this is where I left off. This is what I've been able to crib together. And when we run this function, so I'm going to come in here. Ooh, we're just up in here. Okay. Let me select everything and run it. Then what should happen is loading all the libraries, which are up at the top of the code, which are needed. And then it is supposed to, yes, going through and doing all the logic. Some of the things I asked for in it was to give me the names of different columns. So there's that, and to give me finally a viewer map. So we have that, and you can see here if I click, there are different procedures that it went through. It created this map first, and then it created this map because I have two different plot actions going on using the viewer. And so when we do the perform the spatial join, and then we come in and then we plot it with ggplot, that's what we're seeing. And then we did it again in leaflet. So there's also a plot. Well, ggplot was this, and then leaflet was this, with two different leaflet plots. One is leaflet and one is leafgl. So this is leafgl and this is leaflet. Both of them have the ability to find the intersections and to click on various features, as you can see here. The GL doesn't turn into a finger when it clicks, but it's doing the same thing. So these are two different ways of displaying the data in the viewer with an interactive map, big world map. And then up here, the ggplot is not under viewer, it's under plots. And here we also did several forms of plotting, as you can see. So it's stacked in the sense that when you go through the code, each time that we did a plot, like ggplots here, or plot the New York City neighborhoods, we did a different plot, and then we did an overlay, and then we just continued to run different plots until we ended up with this one. That was the last one we did before we then turned to here. Okay, so then what we're going to jump into is the next half of this. And this gets much more complex, so this could take longer, because what he asks us to do...
I do the same thing instead of add polygon, and it plots it. If you want the polygons underneath the dots, you say add polygons, give it the polygon data frame. Then add circles, give it the dots data frame. And you can see here I added an argument, popup equals tilde and tname. If you click on a polygon, it pops up with the neighborhood name. Same with the circles. If you click a circle, it pops up with the station name. You do tilde bare column name. So we have leafgl.
So then I did
polygon. Now when you do this, because different, let's go ahead and plot a choropleth by mapping it to the domain. If I use regular leaflet, let's go ahead and plot a choropleth. If I use regular leaflet, I have to first create a color palette by mapping it to the domain of the counts.
And he makes it sound like this is going to be really tough, and it probably is. But since he's already done the work, we might as well put it in our code and then see if it actually plays. So let's go down to here and let's move this over, and let's see if we can get this information in here. So he has doc palette, which he's creating, and it's a single L, doc palette, and then he defines this object as color quantile, and then palette equals, and then quote dark 2, and then we have to put in a comma, and then domain equals count by neighborhood. So that's in there. And let's see, we can't see this very well. Count by neighborhood And right after neighborhood, he has $N. Okay. And then he has a comma, and then NA color equals transparent. And then we've got the closed bracket. All right. And then he has leaflet, and then inside element ID equals docs hoods count, and then it closes the bracket, and then he has a pipe, and add tiles, and then another pipe, less sign, and then add polygons. I like the autofill. Data equals count by neighborhood, comma, opacity equals 1, comma, color equals black, comma, oops, put my mouse there, black, and then fill color equals tilde doc underscore palette, and then bracket n, and then stroke equals true, comma, weight equals 0.5, and then close bracket. So that is what is showing there. I don't know if this is going to work at all. Let's see. So let's run that part. So we're going to run all that and see what happens. Yeah, it did work. All right, good. I also want to ask ChatGPT what this pipe thing is. So I say, good morning, ally. Can you explain the symbols pipe symbols pipe this in an English a child could understand, maybe with metaphors or analogies that are memorable? Can you provide a plain English description of this code? And then we'll do that. And let's see. Let's break this down as a child would understand it. Imagine you're building a magical map. The color is a different area based on how many people live there. Think of it as a magic conveyor belt that moves things from one step to the next. It's like a Lego assembly line. We're going to make a Lego castle. First you build a foundation, you pass it along to add walls, and you pass it along to add a roof. Each time you connect the steps together, so the castle keeps growing without restarting from scratch. Make a color palette. This creates a color based on it. How many people live in each neighborhood? Think of a paint bucket that knows what color to use based on a number. Start a new map. This says, hey, let's make a new map called Doc's Hood Hound. Add a base layer. This adds earth. Then you have a blank puzzle board. Add the color pieces. Border black lines, fill color, paint bucket, slight stroke equals 2, thin edges. This code presents a conveyor belt for colors based on how many people in each area. Blank map adds streets and landmarks called neighborhood. It's like painting by numbers where the map chooses base. Conveyor belt passes the map through different stages to more details. Okay, that's pretty cool. What does it mean? So how do we refer to the conveyor belt? Is it pipe greater than sign, or is there another way to describe the characters? Let's see. Pipe operator, because it pipes, passes from the explaining it. Pass to, start with this, then pass to the next step, and do. Make a map, then do tiles, then do. Then do copy, then make it fun metaphors, Lego, conveyor belt. Piece for one. Spell chain, pizza making line, start with that, and then do sauce. I read aloud. Most people say pipe, pipe forward, or just pen. For example, can be read as leaflet, then add tiles, then add polygons. So move forward pipe and R, older pipes, and the Greek package work of some syntax. Okay, well that is very good to know because we may be working with Magritte. All right. So let's see what's.
And then I have to call add polygons and say fill color. It's a whole thing. I don't like it. It's a huge pain. I'm just going to skip this slide and move on to a better slide, okay? Before I get into the better thing though, I said, well, maybe I could zoom in on the plot. And you zoom in by saying set view. I say set view, give it the center of the view with longitude and latitude, and I set my zoom at 11. The default is 10, it can go from 1 to 15.
Let's see where that is in our code. So this is where, oopsie daisy, this is where we had leaflet element ID, docs hood count. Actually not zoomed, I don't see that. I need to see if I have that anywhere. So element ID equals docs hoods count zoomed. So I don't have that anywhere. All right. So I did not put that code in there. So I guess I can come in here and then say leaflet and then element ID equals. I know I'm going to pause this. You don't have to watch me type this in. All right, so we have now run this bit here, and it did. You can see if we run back to here and we run, then the first thing we're going to get is this map, and then if we run this set on 11, oh, I thought that would zoom it in. I was showing that you can run it like this, and it zooms in. Okay, so that's that. I also was asking about the tilde, so I asked ChatGPT about the tilde, and it said it's to avoid having to write a loop. It's applied this function to each value in the data. For each neighborhood, use docPalette to pick a color. So instead of writing a loop, it applies the color function to the n values in count by neighborhood. A magic paintbrush, calculator button, fill in the blank. For every n, fill in the color. And it's used for a lot of other functions, particularly for regression models or anything where you need to predict something based on something else and not have to write it all the time. So you put that tilde in. So that's a good thing to know. And now we're ready to move on to here.
This is a little bit easier to read, but it's still hard to read that choropleth, right? It's hard to make out the colors. It's a little too busy. So I thought, well, let's change the base map. By changing the base map from OpenStreetMaps to CartoDB Voyager, it's a little simpler. The background is a little plainer. And the way I did that was I switched from add tiles to add provider tiles. Now, the version of Leaflet on CRAN does not work with Quarto. So I had to go make a pull request, which has not been reviewed yet, to fix it and tell it where to download JavaScript files. It works. Hopefully it'll get merged into crayon, or hopefully Quarto will get fixed, or one of the others. But you can see it's a little bit simpler of a map here. It's still hard to read, right? And I still have to define the palette myself. So I'm going to turn back to Leaf GL. When you use Leaf GL...
I'm curious, if he's made this work, then maybe it will happen, because it was 2 years ago when he did this. So I'm going to go and see if we type this in to our code and see if I get the same thing that he got. First I'm going to rerun this to go back. And now I'm going to come down here and add his code in to see if it does pull off of this CartoDB Voyager. So we'll start typing that in. You don't have to wait for me to do that. All right, so I've typed it all in. I hope I typed it in correctly. Let's see if we run it, whether it actually works or not. So error in add provider tiles, unused argument, dependency location here. All right, so we have an issue here. Dependency location. Did I write it wrong? Or let's see, dependency location, and they have it dependency location equals here, and it doesn't like that. All right, then let's ask. Let's go back and let's see. Okay, thanks, ally. Can you suss out where we've gone wrong here? And also, what was I going to ask also? I wanted to know as you go here, fill color, dock palette end, stroke is true, set view, add polygons. Pipe takes us there. Oh, I wanted to know what the difference is between, so what's the difference between using and using plus? And let's see what we get. So it's analyzing it. We get code, and it seems to be this line. Problem, it's not a valid argument. It's not accept that, which is right here. Just remove that part. This is used R from function chaining, pipe operator. Example, you'd like make a map and add tiles, then add polygons. Okay. Plus operator and ggplot. Okay. Layer visual elements. Doesn't pass files but add new components to a plot. You'd start a plot, add points, then add a smooth line. Not interchangeable with that because it's not a functioning pipeline. Use that when, use the when. If you're passing data to functions sequentially using graphical elements, functions take their first argument from the previous function as layer. Okay. Fix the dependency location error, use that for leaflet maps, use that for ggplot charts. All right, thank you, infinitely patient tutor, which is really good. All right, so it says just remove this. Maybe that's what he said he rewrote. So if I take this out and now put this in, let's see if in fact it works. Yes, it did work. All right. So apparently they did change it and it doesn't need that. But we do have now this new map, which makes it easier to read. That is good news. So let's save this. I will provide this code painstakingly put together for those of you in the class. I'll put it up in our canvas, so don't worry about that. I'll put it up here in come in here for a moment, and I will put it It takes a long time to load, doesn't it? So I'll put it in our course and put it in our modules, and I will put it in data for QGIS. Maybe we should make another one data for R. We might as well. Let's make another module, and let's call it data for R for mapping, and then add that module. So we're going to end up way down at the bottom, and then we can bring it way back up. Takes so darn long. Come on, come on, come on, come on, come on. Let's go up here and put it in storyboarding, editing, video editing, script to screen. There we go. Data for GIS, there's data for R. And then to drop files, we would put the file in there and we make it visible. And then we have to choose files. And right now, the first half of the file is actually in our downloads. It's part 1's code. So we'll drop that in there. There. And then we'll drop this one when we're done. Okay, so good. And so we've got that working.
But you can see it's a little bit simpler of a map here. It's still hard to read, right? And I still have to define the palette myself. So I'm going to turn back to LeafGL. When you use LeafGL and use addGL polygons, you give it the column you want to control the color as in quotes, and it figures out the color palette for you. And in my opinion, is using much more attractive colors than the one I had selected earlier. Yes, I selected the colors before, and I chose poorly. addGL polygons chose wisely, and I think this is much easier to read. I'm much happier about this. And if you want to add points on top of a choropleth, you just say addGL points on top of the previously existing polygons. And that's it. You build it up iteratively, layer by layer, just like you would ggplot. So far, I've been making my choropleths by neighborhood, which are these arbitrary.
Okay, so let's type this in. And
if you want to add...
Let's do this, and then we'll come back and we'll add the points on top. So I'm going to pause this and type this in. Okay. And there we go. I think in this case, I'm not going to use dependency location equals here, because apparently it doesn't need it anymore. So I'm just going to close this bracket here, and then I'm going to put the pipe here, and then go down to add GL polygons, as he said, and then do data equals count by neighborhood, and then right within that we have another pipe for some reason, and then stcast polygon, and that's capitals, and then after that put in a comma, put in your opacity equals, opacity equals 1, and fill color equals n, and then close the bracket there, and then pipe that to set view, and then do our longitude equals negative 73.85, not that that really matters. Latitude equals 40.75. Wouldn't matter if you care about that specific part of Manhattan. Zoom equals 11, and I think, oh no, there's a mess here. So what's going on here? This bracket corresponds to that bracket. This one corresponds to that. That one corresponds to that. And that one corresponds to that. All right, let's see if that does anything. So Let's save this. And let's give this a try. Yeah, got exactly what he showed. That's nice. And then he says,
points on top of a choropleth, you just say add GL points on top of the previously existing polygons.
All right, so add those choropleths. Somebody called them choropleths. So we want to add on top of this, we want to add GL points before we do the set view. So we've ported over. Now we say add GL points data equals docs, and then equals docs, and then pipe it. And so if we run this again, there's our data points. Okay, good. Now, there's no pop-outs there, but at least the data points with all the bike things are there as we expected. So,
and that's it. You build it up iteratively, layer by layer, just like you would ggplot. So far, I've been making my choropleths by neighborhood, which are these arbitrarily defined boundaries based on some bureaucrat in the city. So instead, I want to use hex bins. I want to bin up my data into small hexagons and plot the density of those hexagons. Now the question is, how do I get these points into hexagons? Thankfully, there is a system called H3 put up by Uber, which is exposed to us by the H3 JSR package. And this maps any point on the Earth to a hexagon. And the whole Earth has been mapped to 15 layers of hexagons, from really, really tiny to really, really big. So all I have to do is give it my geometry column, and it maps it to an H3. It gives me a specific H3 index. And then I'm able to convert that H3 index back into a polygon. So now I can make a choropleth based on the polygons. I simply do. So all I have to do is give it my geometry.
Okay, I guess we're going to do that. I'm going to ask choropleth and say what do they mean in GIS by a choropleth, or am I spelling it wrong? And it thinks. So choropleth is a GIS term. Choropleth map is a thematic map where areas like countries are colored or shaded based on a data of choro, area, or region. I thought it was chloro from color. Okay. Choropleth, meaning filled. Choropleth. Map areas filled with some data. Each map is color coded according to that of data. Choropleth. Darker shades, lighter shades, darker, higher unemployment rate. Choropleth. Heat map. So there's difference in choropleth based on inside boundaries and heat maps with no strict borders like weather and dot density. Having a choropleth and leaflet with this line, colors based on N, like Kadox or population. Just a painted map that represents data inside geographic boundaries. So the best thing is to know that choro means area. Filled region. All right, a filled region. Now that we have this, we need a library, which I think we should put all the way up at the top. So library, and then H3JSR. Now, I don't know if we have that, so we're going to have to look and see in our packages and look for H3. Nope, it's not there. So can we install it? So let's look in CRAN, H3JSR. There it is. All right, good. So we'll install it. And now we've called it. And let me load this by running this. built. All right. So then we come down here, having loaded that in, and we're going to add all of this stuff here. So I'll pause for you. All right, so here we're going to define docx as, this is defined as docs, and then we're going to do the pipe and say that we are going to build onto this select and select station name, but we know it's not called that, it's just called name in ours. We had that problem before, so we're going to say name in docs, and then we're going to put this pipe to mutate hex equals point to h3, and then in there put geometry resolution equals 8. Those get closed, and then pipe that to st drop underscore geometry. All right, that shows up, and then pipe that to count hex, and pipe that to h3 underscore 2 polygon simple equals false, and then doc underscore hex, which should tell us what, that should give us this stuff down here, the polygons. It gives a printout. So let's try running this and hope that we get something. I'm going to save this and hit run. Error. Function. Maybe it just needs to run completely. Let's try it from the top and see what that does. So we start getting our printouts from our other function calls. I do need to go to those plots. Okay, those plots are happening. There's other plots. It's another plot we did. It's running the program to that one, this to that, and then it says error. All right, so it doesn't know what to do with this. And let's see, the library is there, but it says docx is docs. I said that right. And then select name, then mutate hex equals point to h3 geometry spelled right, res equals 8 double bracket. Oh, I don't know where this, oh yeah, just a bracket, then count st drop underscore geometry, and then count hex, and then h3 to polygon simple equals false, doc hex. All right, so it looks correct, but we're not getting anything. So let's take a screenshot and let's find out if ChatGPT can help us. Thanks again. Now got this error message. See what it says after it analyzes the picture. What's going wrong? It doesn't recognize H3 polygon. The H hash is not installed or not loaded. You're going to use your own package or missing required library. Install the missing package. And load it in your session. All right, test it. All right, So what I'm going to do first, I'm going to take this library. I'm going to cut it from here and bring it in down at the bottom so that, and then before I run it, I'm going to put in this check that they've asked us to do, check if a function exists. So let's put in this check, and then let's do this and run just that. False. Okay. False, there might be a typo or another issue. Try reset a geoboundary. Final fix, try this corrected version with the geoboundary. All right, let's try that. So let's put this in here. Oopsie. All right. I'm going to take all this out and put this in. What did that look like? We had, let me leave docx in. Let me take this, let me be smart about this so I can compare them. Let's put the corrected code there and the uncorrected part there. That's the H3 thing, geometry is false. So we don't know if that works, but let's try H3 to boundary. And let's put that under exists. And then let's try that. False. No, let's try this. One or more packages to be updated are currently loaded. All right. So I'm going to comment that out. And the library's there, and then let's see if we can get this to run. Error. Okay. In that case, we do this hunting that we've been doing. So, nope, didn't work. Nope, didn't work. It did not load correctly, and functioning with. All right, let's try this then. So let's do this down here and check and see if it is true. Okay, so it did load. That's good to know. The next thing to check is list all functions inside there. see. So install functions. So let's install the functions and see what we get. Get disk. Okay, these are the functions, and we're looking for H3 to something, but there is no this H3 info table, but there's no H3 to geo boundary. Here is the list. Since there's no function, you need the correct alternative. Try cell to polygon. Okay. It's actually gone to cells, so H3, instead of that, we use cell to polygon, and then polygon to cells. Also, I noticed you're using point to H3, point to cell. Final working code. All right, let's try this. So, go back to here, and we don't need this anymore. I'm going to take this out, and then go like this. And then let's see if we can get this to run. Could not find function count. Now I get gotta run Dippler. Alright. It's not a base R function, it's part of Dippler. If it wasn't loaded, it doesn't have to do with it. Aggregate. Let's try Dippler. I should have Dippler in here because Dippler was way up at the top, but let's try this and then run all that just to make sure. This is a heck of a lot of troubleshooting. So I'm gonna get SF to run in there. Come on, seriously? It sounds crazy, but yeah. So let's go into here. And let's try that. It's sort of been loaded from the front, and maybe they're just not loaded in. Ah, there we go. Finally. All right. So that seemed to work. A lot of troubleshooting. So let's go back to here. Let's see.
Column, and it maps it to an H3. It gives me a specific H3 index. And then I'm able to convert that H3 index back into a polygon. So now I can make a choropleth based on the polygons. I simply do a count on that, and it tells me everything. I'm all done. How nice and simple is that? I know.
Simple, huh? You call that simple. Good for you. All right, so then after we do the docs hex and we see that, we say leaflet, and then element ID equals hex counts, and then we have pipe to add provider tiles, carto db.voyager, and then dependency location we decided we're going to leave out. So after that we put in the bracket, and then we put in the pipe. 2 add GL polygons, and then the data equals doc underscore hex, opacity equals 1, fill color equals n. And let's hope that this will run. Error. Could not find add GL polygons. Really? Looks right to me. Data equals doc hex, opacity equals 1, fill color equals n. Let's drive me to distraction. Get more errors, even though the last function did run. This reliance on AI slowly helping me to understand. Add polygons. LeafletNar does not have a function called add GL polygons. Add polygons. But what did we have before? We had something working with the GL. Back here we had GL points, add GL polygons. So it was working before. Is that because we had a LeafGL library? So that's the problem, probably. Seems like it's forgotten everything that we're telling it to do. So let's try this. And let's see if that works before we do anything else. No applicable method for make color matrix. Make color matrix. So actually, I didn't need to change the code because all I needed to do was load the LeafGL library. I get this now. Right. So LeafGL was LeafGL like that. Like this, and then good catch. We needed GLeafGL for that. Makes sense because it's specific to LeafGL package. Make color matrix. Suggests that fill color is not correctly defined and is being treated as a function not mapped correctly. Use a color palette. Use color numeric. The issue tries to use n as a static value instead of colors. Applies a color function. Let's try this then. Cobbling it together little by little. Oh shoot. So if I bring this down, oh wait a minute, I want to make sure I'm doing this right. So we need leaflet and create a color palette. Is this inside add? So how does that map onto what we have here? polygon. This is the fill color leaflet. All right, I'm going to put this underneath and then compare it. So here we are saying create a color palette, leaflet, add provider tiles. All right, so I can get rid of this. We don't need that anymore. Instead, we're creating the color palette, and then we're basing it on that. So now, let's run it. And doesn't seem to have changed. What if I erase then all the history of this? Let's go all the way back to the top. Select everything and run it all. And let's see where we get stopped. All right, so it's running through again. Probably going to plot all of that. Yeah, there's that. So now we're in the viewer and we're going through, and we got to there, and then I suppose that's the right thing. So it did give me an error. But let me see what he says in here. He says that.
I went through the slide really quickly, but the code's all up there. You can check it out. Nice, easy way to do it, and it's really big help having these H3 hexagons. That has managed to compute my GIS processing when I'm actually doing real statistics on this by about 100-fold in speed. It's made a big difference.
All right, so that did not work. And for us, we're looking at it and saying, all right, leaflet, element ID, hex counts, add provider tiles, and then add GL polygons, the data equals doc hex, opacity equals 1, and the fill color equals that, and it's telling us that. All right, so what I want to do, I want to see if I can, let's see, I know you go through this too all the time, right? Oh, that's too big. No, I can't do that. Maybe I can make this smaller. No, it's not going to work. Oh, well, I'll just take two different. Maybe. So let's go in here to chat and say that, and then go over to our R. Mm-hmm. All right. So I'm not getting the same result as tutorial. No hexes, colors. Some error now about meta. Glad it's so smart because I feel so stupid. Earth has been treated as a geometry only, meaning does not contain associated attributes. Looks like when you ran this, you dropped the geometry and then transferred it back to hexagons without merging it back to attributes. Your docx only contained geometry with missing n, which is needed for coloring. Ensure n is preserved when already read. Reattach n after conversion. Step-by-step fix. Convert points. How does this fix work? Keeps the values. Alright. So let's do this again. Let's copy this and bring that to, I don't know, what am I doing here? This is going to be tricky for me to keep in my head. Docx data, and convert it, and do the leaflet thing. All those things. So, if I take all this out, and then go like this, and then run it, it worked. Oh my gosh. Look at that. Ain't that pretty? Thank you very much, ChatGPT. I'm not in a position right now to fully explore and understand everything it's telling us. I'll have to do that as my mind iteratively learns more about this, but it is working. That did work, so I will let you know. It worked. So back for that. That's good feedback. I should say thank you. Fantastic. I'm so glad it worked. Properly colored hexagons with web geometry. Yeah, very nice. Thank you. Happy mapping. Thank you for that. All right, so we go back then to.
And Leaflet has all sorts of other cool features we could take a look at. Right here, I added just a few things. You'll notice in the top upper right corner, there's a little measuring tool. If you click that, it's an interactive tool where you can measure the distance between different points on the map. You can even make a little polygon and measure the distance between the polygons. On the upper left, I added a logo, and then you'll see this function add mouse coordinates. You can't see it here, but if I were to move my mouse around on there, it would show you the latitude and longitude of wherever your mouse is pointing. But let's say you don't want this boring map as your background. You want a satellite view.
All right, then we will get to that. That is getting exciting. But let's get to this part and put this in. So let's see. He's giving us other cool code stuff. Putting in a library called leaf.em. And then from there, going to leaflet and doing element ID equals cool things. Neat. And piping that over to add provider tiles and then cartodb.voyager and then a comma, and then we don't need the dependency location. We've determined that thanks to our work with ChatGPT, so no comma there. But come here and pipe that to add GL polygons and then say data equals doc underscore hex, which is down here, and then put a comma, a period, and say opacity equals 1, fill color equals n. We'll probably get an error with that, no doubt. And then add measure, and then measure, add mouse coordinates, and add to that, pipe that through to add logo image. This image equals here. you'd have to have that. So if I wanted to put an image, I probably would want to put a path to an image. I mean, I suppose we're in the thing here at the point where you'd have to know what image you wanted to use. And for me, what do I want to use? I suppose I'd want to use material means cooperative, and what do I have here? I have photos, and I suppose I could take a pistachio tree, small pistachio tree with fruit. I mean, copy his path. Probably get this wrong, but I imagine I could go put that path in, but then I'd have to change it all to these forward facing slashes. I don't know what it's going to do. It's a WebP also, so that's not going to work, I'm pretty sure. I should have taken something else. I should have taken a JPEG. I'll take a JPEG and I'll copy the path and then change these like this. That'll be my logo for now, just to see if it works. I don't know why it has. Oh no. No, I'm supposed to do that. Alright, that's the add logo. And then source equals remote, whatever that means here. I'll have to ask ChatGPT to help us with that. Source equals remote.
Your mouse around on there, it would show you the latitude and longitude of wherever your mouse is.
We don't know what the end of that is supposed to be. I guess it just needs a closing bracket. So it can work. But let's try it. Let's oh, what is it telling us here? Unexpected token. Who's the unexpected token? Let me just see, does this look correct? Does this look correct? Two syntax errors. Issues in your code. Fill color. Variable not a string. Use doc palette. Misplaced in add logo. So there's the fixed code. Okay. Use doc palette, add logo, syntax 91. Okay, let's try that out. Alright, so try that. Error, could not find the library. Oops, I meant to run it like this. I didn't do that, that's wrong. So let's try it now. No metadata. First of all, let's see in our packages, do we even have leaf EM? So we go leaf EM, yes, we do have it. So that's there, don't worry about that. So I'm gonna have to get chat to fix it for us. Alright, so plot viewer and go here. Okay, it's gonna think I'm so stupid. Got an error. And the error is envelope, please. Suggest the docs still appear geometry without an associated data frame. Looks over your doc hex step we already hexated polygons. SF geometry and data. Run code name design and deliver that. Recreate data geometry. See this part here. This part here is docx data docs. And put this down. Close this up. And say in here. SF leaflet. GL docx data. Docs. Select, mutate, convert docx IDs back to polygons. So we need to get this in here. Where we have convert plots. So we can take that from here. One in step 2. But we do need to do, what was it called? Library HG, H3, GSR. Okay. So we do that, but after we've done that, so let's see what we get when we run this. Say run. Get the map. And we do get that. Okay, we got the desert distance. Create a new measurement. That is very cool. The logo never showed up, but we do get that. That's really neat. Finish measurement or cancel. We do have a zoom function. We don't have the. That's pretty neat. So we have the measuring tool. What does he have? He has his logo. Okay, so I can say it worked except for the logo. Define a color palette. First, let's define a color palette. Doc. Put this in here. And let's run that. Color palette isn't very interesting. And then under the leaflet map. I want to make sure didn't do anything. So it worked great except for the logo. Let's see what it tells us. Incorrect source tech. Remote is used for online images. For local images. So we should do this. All right, let's see. Yeah, there it is. There it works. So how would I use a remote image? So he has in his lander, he does this let's do this. Say thanks, that worked. Now how do I put in another logo remotely like he does here? Let's see what that does. So if I do this and this one becomes remote, then I can make it top left. So let me do that. Add a logo and make it instead of bottom right, which is what we did here, I'll make it top left. Top left. See what that does. But I'll put in my image. So I should be able to go to my Facebook. It should be really cool if I could do this. And I should be able to get a picture like this. Or let's see if I can find another one that I want to use in my photos. Let's use drawdown. So copy image address and come into here and put that in. Whoa, that's a big long one. But I do want to try that. So let's see if that works. No, it didn't like that one. All right, let's take this all out. And let's find something that is simpler. And all of that is really long, isn't it? Oh God. What if I just go Control Z and then let's find a picture on Google. And let's call it Culhane. Or let's say TH Culhane. Where's a picture? And let's see if I take this, copy image address, put that in here. It's also hugely long. Can't do that. Logo URL. I don't know. Copy image address. I mean, how big? Where do you find an image address that isn't so long? Well, at least that's a JPEG. That may work. Let's try that. All right. Nope. It doesn't like it. It says argument missing with no default. Image equals. I'm going to ask it. Let me say, when I put in a image address, I get an error. And let's let it figure it out. And I'm going to fix. Let's go to the map in M. Let's see if that works. So here we will put that in. And let's try to run it. Code to drop in. Meaning I don't want to think. Okay. Let's try this. Okay. Let's try it out. Well, it didn't give me the other one. So maybe, oh, that's an example. So what if we put in this and then go back and try it out? Nope, still didn't do it. Doesn't say why, but it didn't do it. Maybe it's blocked. Don't know. That's from Google. And if I try to take this, copy image address, and try to put that in instead, it doesn't even have a, it's encrypted. That's weird. Yeah, it's not going to work. All right, well, it doesn't work. Image equals. It's encrypted, maybe? change address, and then put that in. Try that. Top left. What's the bottom right? We did have that. That would overwrite then the pistachio. Bottom right. So we can try that. No. So clearly it's not working there, but that's all right. I don't care so much about that. Let's go back and see where we were here.
Pointing. But let's say you don't want this boring map as your background. You want a satellite view. Well, we use add provider tiles yet again. And this time I'm saying use Esri World Imagery, which provides 15 layers of zoom of satellite imagery of the Earth. But you'll notice I also have CartoDB up there. And there's a radio button. I'm able to flip between the different maps. If I click that radio button, I can switch to OpenStreetMaps or back to Esri Satellite View. I can also turn on and off my docs points or my hexagons. I have now allowed the user to have full control over their map and say, take away this layer, switch to this map. All this control, all of just a few lines of code, so simple for me to make.
That's great. So here in more cool things, let's go and look at, we have add provider tiles under, oh, this is more cool things. So step 2, add a local link. So let's put in that in, say leaflet, and then elements ID equals more cool things, and then go from there to close bracket to the pipe, and then let's go add provider tiles and pcarto db dot voyager and tell it to group equals streets, and then comma. We don't need that dependency location, so I guess we don't need the comma, nor do we need 2 of these. So there's that one there, and I'm sure then he probably then has to pipe it. You know what I'm going to do? All right. This is where AI comes in very helpful. Thanks. Still having errors display though. No error codes come up. Let's leave that for a second. Instead, can you make this code work for me? I can't scroll to see the end of it. Okay. All right, so this is what we have, so I don't have to type it in. And let's get rid of that. Let's put this in. Uh-oh, layer control didn't finish. All right, so we need to copy that. Now let's redo that. What the heck? More cool things. All right. more cool things. You don't need this. It's redundant. Let's see if we can get this to work. Just an example. Ah, cool. All right, so satellite view, beautiful. Street view, no pop-ups, but, and then there's just an example there. The hexes can put on, the docs can be put on. That's pretty neat. All right, that's spectacular. And where's this just an example? In here, add a remote logo. Oh, example, right? But that's very, very cool. All right, and then finally.
So that's a lot of lines to make different plots. So far we've done the spatial join, we have made a bunch of different plots. So now it's time to play a game. And when I finished the talk, I actually wrote my talk ahead of time about a month ago. The most popular game going around was Wordle.
All right, so playing a game will be for the next stumble through. Looks like we got done what we wanted to get done here. Obviously, if we wanted to put in our own image, then I could take my add logo, local logo, and put that, bring that down into this piece of code if I want. That's top left, and I can put in my logo there. And let's rerun this and see if it puts my image in. It didn't. Can put the satellite, but my logo didn't come in. Let's see if I take out this M thing. And now run it again. Add logo. I'll add two logos to this, so I'm going to take this out of there, put this logo, and then do the same thing down there. All right, let's see what that does. Oh, it says argument map is missing. Well, that's something to work on another time. All right, so long.